In the previous part, we implemented a function that returns initial state for the app. And now we'll write a function that generates initial state for the game. The state will have the width and height of the field. Game on the background has size of 17 on 15. We will measure distances in cells. A state will contain initial snake length and direction. All directions in the game will be represented as a vector with a length of 1. The state will keep the position of the food and coordinates of the snake nodes. Positions also will be represented as vectors. Also, we will have the current direction of the snake, score, and speed. Let's go to getGameInitialState function. This function receives config, and this is an optional parameter. We can omit any parameters to this function and will be used default config. So first we are taking all these parameters from configuration, and we are making configuration by merging default config into received config. So default game config, and now we need to create this config. We are doing this in constants region. So first is going width. We can think of width as number of columns and height as number of rows if you think in cells. Speed is how much of the cell we are passing in 1 millisecond. Initial snake length equal to 3, it means that length of our snake at the start will have length of 3 cells. And direction is right. We can find the use of vectors in almost every imaginable type of game, and it is very important to know how they can be applied and what are the most popular operations are. In our game, we won't have a dedicated class for points because vector will be sufficient both to specify the directions and coordinates. If you're not quite comfortable with vectors, I highly encourage you to check out my articles that you can find in the description. There I show the basics with JavaScript examples. We will always represent directions as a vector with a length equal to 1. By using this convention, we can move the snake head by adding its direction scaled by the distance. Also, we'll assume that y is pointing down. It is easier to think this way because on the screen, coordinate starts in the top left corner. For now, we will implement constructor and then add different methods as we need them. Snake will be represented as an array of nodes coordinates, and we'll start from the tail. But in order to find position of the tail, we need to first know the position of the head. Head will be placed right on the center of the game field. To calculate x component, we need to divide width by 2 and subtract half of the cell. To calculate y component, we need to do the same with height. Then we can calculate position of tail tip. To do so, we subtract initial direction scaled by the length of the snake. Now let's go back to vector class, and here we are going to implement these two methods. To subtract one vector from another, we need to subtract from one vector component another vector components, and then we return new vector. Important moments here is that we always return a new value. We don't mutate the state of the vector class, and the same will be applied later for segment class. So this class can be called immutable. In order to scale vector, we need to multiply vector components by number. Now let's go back. When we know coordinates of tooltip and head, we can create snake. So we're starting from the tail end and go to the head. Now let's get coordinates of the food. To find the coordinates of the food, we need to know number of rows and columns and position of the snake. We need to know position of the snake in order to place food in the free from snake position on the game field. For now, we'll simply return position in the top left corner, and we'll implement this function in later parts. And we are ready to return game state. It contains width, height, speed that we are taken from our configuration, initial snake length, so that when game is over, we can take this length and direction and create a new state. Then current direction on the start will be equal to initial direction position of the food. Current score, so we are starting from 0. And let's test this scene. To do so, we add console log and comment out, set timeout. Let's reload everything, go to the game object, and here we can see the direction pointing to the right, position of the food, initial direction, initial length, snake. As you can see that different only X component here, speed and width. So that's it. Let's go back and update everything. Check out my app at increaser.org, designed to help you stay focused, make work done, keep progress, see if you give enough time to projects, and find unproductive patterns. By working with the app, you will build discipline and self-accountability that are required to succeed.